Good day everyone, we are Group 3 and I'm Crystal Faye Jilin Sangan, and for today's video discussion, we are going to talk about the nanotechnology. First, let me discuss the learning objectives of it. First, explain the concept of nanotechnology. Second one is discuss the application of nanotechnology. And the last one, discuss the major impacts, both potential and realized, of nanotechnology on society. And now, let me discuss what is nanotechnology. Nanotechnology is a technology that manipulates and controls a substance at the nanometer level. So, the nanometer level is the level of atoms and molecules, and it is used to develop noble materials and gadgets with exciting functions that take advantage of nanoscale substances' unique features. So, let's talk about more about the nanotechnology. Modern industrial nanotechnology had its origin in 1930s in processes used to create silver coatings for photographic film. So the Abbasid dynasty used the nanoparticles for the first time in the 9th century. Nanoparticles were employed in the Arab blades to allow things to change color depending on the viewing angle. So the next one is that the properties of materials can be different on the nanoscale for two main reasons. First, nanomaterials have the bigger surface or than the same mass of the material produced in the larger form. The second one is that below 50 nanometer, conventional physics will lose way to quantum effects, resulting in optical, electrical, or the magnetic properties that differ from those of the identical materials at the greater scales. And now let me discuss the three of the most talked about nanotechnologies, such as the carbon nanotubes, the nanoparticles, and the quantum dots. So first, let me discuss the carbon nanotube. Carbon nanotubes is the long thin cylinders of atomic layers of graphite. So these carbon nanotubes are single work carbon nanotubes with sizes in the nanometer range. So the second one is the nanoparticles. Nanoparticles have been used since a quantity by the chemists in the China and the West. So a nanoparticle also as an ultrafine or ultrafine particle is a small particle of matter with a diameter of between 1 or 100 nanometers. So the last one is the quantum dots. Just as carbon nanotubes are often described as the new plastic, so quantum dots are defined as the ball bearings of the nano age. Quantum dots are like artificial atoms. A nanometer size or semiconductor particle with a core shell structure is the plastic stance of it. Quantum dots are frequently employed because of their unusual optical features, which include the ability to emit light of precise wavelengths when energy is applied. So that will be the end of my discussion. My other groupmates will continue our report.
Good day everyone. I am Joanne Gabanit from BPED 4B, and I will going to discuss some of the uses of nanotechnology in consumer product. So first, a glass of windows which is coated with titanium oxide nanoparticles that react sunlight to break down dirt. When water hits the glass, it is spread evenly over the surface instead of forming droplets and runs off rapidly, taking the dirt with it. Second, nanotechnologies are used by the car industry with regard to paints and surface coatings. Nanostructured surface result in improved paint adhesion and color durability. Self-cleaning will become standard on windscreen and car body shells. 3. Sunglasses using protective and anti-reflective ultra-thin polymer coatings. The films reduce the reflectance of light, and in case of eyeglasses would capture more light, reduce glare, and also reduce exposure to ultraviolet light. Fourth, textile can incorporate nanotechnology to make practical decisions. The unique properties of nanoparticles and nanofibers mean they can be used to design fabric with excellent. The windproof and waterproof properties of one sky jacket, for example, are obtained not by a surface coating of a jacket but by the use of nanofibers. Fifth, sport equipment manufacturers are also turning to nanotech. Nanotechnology in sports equipment also help to make a line of coating of nanoparticles on table tennis to change the property of inflating as air cannot be evaded from the core of the ball that helps to decline in the ball replacement. 6. Sunscreen and cosmetics based on nanotech are already wide as the two main uses for nanoparticles in cosmetic products are UV filtering and delivery of active ingredients. Titanium oxide and zinc oxide are both used extremely the sunscreen to prevent UV damage to the skin. The nano formulation of these materials have been shown repeatedly to give much better performance than larger particles, reflecting visible light and absorbing UV with very high efficiency. And last, television using carbon nanotubes could be in use by late 2006 according to Samsung 16. The new TV screens are a nano version of the field emission displays developed by Motorola and others during the 1990s. Although that technology produced dazzling prototype displays, it costs too much to compete with liquid crystals displays. And moving on to Mr. Liwanag to discuss the sum of porcine application in nanotechnology.
Good day, I'm the next reporter, and my name is Leander Mark and for today, I will be discussing the sum of the porcine application of nanotechnology. In the medium term, the following list gives a quick overview of the many domains where nanotechnology is expected to fundamentally change products and how they are produced over the 2 decades. So number one is electronics and communication. Recording using nanolayers and dots, flat panel display, wireless technology, new devices and processes across the entire range of communication and information technologies. Factors of thousand to million improvements in both data storage capacity and processing speed and at lower cost and improve power efficiency compared to present electronic circuits. Nanotechnology in electronics or nanoelectronics. Nanotechnology has helped break down barriers, bypass restriction in the field of electronics. Nanoelectronics refers to the application of nanotechnology in electronic devices, especially transistors. Although the term nanotechnology means using technology less than 100 nanometers in size, nanoelectronics often refers to very small transistors, so quantum mechanical properties and interatomic interaction are required to be studied in depth and extensively. Next is chemicals and materials. Catalysts that increase the energy efficiency of chemical plants and improve the combustion efficiency, thus lowering population emission of motor vehicles super hard and tough. For example, is not vital. Drill, bits and cutting tools, smart magnetic fluids for vacuum seals and lubricants. Nanomaterials can be bought naturally according to man-made. Nanomaterials can be manufactured intentionally and especially controlled to be a particular shape and size. Man-made nanomaterials are created by specific processes that create purposely built materials with certain properties. So next is pharmaceuticals, healthcare, and life sciences. Nanostructured drugs, gene and drug delivery system target to specific sites in the body. Biocompatible replacement for body parts and fluids. Self-diagnostic for use in the home. Sensors for labs on the chip. material for bone and tissue regeneration. Nanotechnology advances are increasingly being used in the life sciences. Nanoscales designs and structures are being used in the sectors like medicines, biotechnology, and tissue engineering. Nanotechnology's application in medicine has considerable promise, with, with new technologies enhancing drug administration and providing novel diagnostic procedures. Clinical the clinical nanotechnology applications are currently happening and will become more common as current research becomes reality. So, the fourth one is manufacturing. Precision engineering based on new generation of microscope and measuring techniques. New processes and tools to manipulate matter at an atomic level. Nanopowders that are sintered into bulk materials with special properties that may include sensors to detect incipient pillars, actuators to repair problems, chemical, mechanical polishing with nanoparticles, self-assembling of structure from molecules, bio-inspired materials, and biostructures. Nanotechnology can also be used to make lubricants that are more effective and stable, which can be employed in a range of industrial applications. Information and Communication Technology or ICT refers to advanced and innovative technology that provide access to information through telecommunications. ICT is an important and fast-growing industrial sector with a high rate of innovation and covers any product that will store, manipulate, receive, or transmit information electronically in digital form.
Hi everyone, I'm Kervin Jem El Domingo. I'm from group number 3. So for today's video, I will discuss the first and application of nanotechnology. So I will discuss first the drug delivery system. Approaches, formulations, manufacturing techniques, storage system, and technologies involved in transporting a pharmaceutical compound to its target site to achieve a desired therapeutic effort. So the second one, I'll discuss the food processing and storage. Basic preparation of foods, the attractions of a food product into other form, as making preserves from fruit, and preservation and packaging techniques. So the third one is the air pollution remediation. Air pollutants can also be mitigated through biological means, commonly referred to as biological remediation or bioremediation. It is the use of organisms to assimilate, degrade, or transform hazardous substances into less toxic or non-toxic ones. So the last is the construction. Basic construction materials, cement, concrete, and steel will be also benefit from nanotechnology. Addition of nanoparticles will lead to stronger, more durable, self-healing, air-purifying, fire-resistance, easy to clean, and quick compacting concrete. And that's all. Thank you.
Good day, my name is Joanna Yuliganson from BPED 4B, and I am going to discuss the nanotechnology and situation of developing country. Energy. Nanomaterials are being used to build a new generation of solar cells, hydrogen fuel cells, and noble hydrogen storage system that could deliver clean energy to countries. So, nanotechnology is being used to reduce the cost of fuel cells catalysts. These catalysts generate hydrogen ions from fuels like methanol. Nanotechnology is also being used to improve the efficiency of membranes used in fuel cells to separate hydrogen ions from other gases like oxygen. Agriculture. Nanotech materials are in development for the slow release and efficient dosage of fertilizer for plants and of nutrients and medicine for livestock. Nanotechnology, with its miniature size, monitors a leading agricultural controlling process. The goal of nanomaterials in agriculture is to reduce the amount of chemicals used, reduce nutrient losses during fertilization, and increase yield through pest and nutrients management. Water treatment. Nanomembranes and nanoclays are inexpensive, portable, and easily cleaned systems that purify, detoxify, and desalinate water more efficiently than conventional bacterial and viral filters. Nanotechnology is used to purify water by utilizing nanoscopic materials such as carbon nanotubes and aluminum fibers for nanofiltration. Carbon nanotube membranes, for example, can remove almost all types of water contaminants including turbidity, oil, bacteria, viruses, and organic contaminants. A water filter is a device that removes impurities from water through the use of a physical barrier, a chemical process, and biological process. Chlorine, chlorine dioxide, and ozone are examples of chemical disinfectant. Disease diagnosis and screening. Technologies include the lab-on-a-chip, which offers all the diagnostic functions of a chemical laboratory and other biosensors based on nanotubes, wires, magnetic particles, and semiconductors. Nanotechnology is extremely useful in medical diagnosis, and various nanoparticles have demonstrated tremendous potential for detecting diseases, markers, precancerous cells, various fragments, specific proteins, antibodies, and other disease indicators. Nanotechnology has the potential to accelerate the development of personalized medicine in which patient therapy is tailored to the patient's unique genetic and disease profile. Drug delivery system. Nanocapsules, dendrimers, tiny brush-like spheres made of branded polymers, and buckyballs, soccer ball-shaped structures made of 60 carbon atoms for slow sustained drug release system. Nanotechnology drug delivery applications involve the use of engineered nanomaterials as well as the formulation of delivery systems from nanosolved molecules such as liposomes. The use of nanotechnology is drug delivery should result in the following advantage: improve ability to deliver drugs that are poorly water soluble. A nanocarrier system or NCS encapsulates or absorbs a drug or therapeutic foreign gene molecule on its surface, as well as couples a specific targeting molecule to the surface of the nanocarrier and then binds to a cell surface specific receptor via targeting molecule.
So good day, I am Lady Linhamen, the continuation of nanotechnology and situation of developing country. So number 6 is food processing and storage. So the importance of food storage and food processing is a proper food storage help to preserve the quality and nutritional value of the foods you purchase and also help make the most of your food dollar by preventing spoilage. Additionally, proper food storage can help prevent foodborne illnesses caused by harmful bacteria. So number 7 is air pollution remediation. So detects toxic substances and leaks, reduce fossil fuel emissions separated gas. So some ways to reduce air pollution is riding a bike or walking instead of driving, turning off the lights and appliances when they are not in use. So number 8 is construction. The basic building materials cement, concrete, and steel will also benefit from nanotechnology with the additional of nanoparticles. They are stronger, more durable, self-healing, air purifying, and you will get concrete that is fire resistant, easy to clean, and compresses quickly. So number 9 is health monitoring. The purpose of monitoring is to see whether a particular intended result or set of results has actually happened after a clinical process of substance has been applied and to provide ongoing oversight to the quality of care given to meet a person's need. So number 10 is disease vectors and pest detection control. So when it comes to disaster and emergency mediators and pest control, it is important to increase the population of mediators and annoying species, usually insects and rodents. So in some disasters, floods can create new breeding grounds for mosquitoes in disaster, rubble, and standing pools. So risk of nanotechnology. When it comes to risk, it is the possibility of something bad happening. So business risk involved with marketing of nanotechnology enabled products. So example of business risk is loss of significant supplier or customer. And risk related to the protection of intellectual property. Some example of it is copyrights, impersonators. So this and all other original creative works of economic value and legal protection can be classified as intellectual property. So, political risks regarding the impact of the economic development of countries and regions. So, political unrest such as terrorism, riots, coups, civil wars, and riots can completely disturb a country's business operation over the long term. So environmental risk from the release of nanoparticles into the environment. Environmental risk of nanoparticles, nanomaterials that land on the land can contaminate soil and move to surface and groundwater. Particles contained in solid waste, sewage, direct influence, or accidental spill can be carried to the water system by wind or storm water spills. So lastly is the safety risk from nanoparticles for workers and consumers. To manage the risk of nanoparticles, employers need to understand. So the hazardous properties of products that contain engineered nanomaterials. The potential for exposure to engineered nanomaterials that may be harmful, and the effectiveness of workplace controls to either prevent or minimize exposure. I am Lidin Bautista and thank you.
Good day, everyone. My name is Vincent Harold R. Fajardo from BPED 4B. So now this is the continuation of our report on Chapter 8. So now let's proceed to the implication of nanotechnology of human health and environment. A fair assessment of the risk of any new technology must also consider positive contribution to increased safety. The basic innovation that comes from the nanotechnologies have the potential to contribute to human health and environmental safety in many ways. They have the potential to contribute to solve urgent issues like the provisions of clean drinking water or more efficient energy conversion and energy storage. The economic growth in the field of nanotechnologies will lead to an increased variety and increased volumes of engineered nanoparticles that are produced, keeping in mind that these free nanoparticles can enter the human body over various pathways. It is important to understand the implication for human health and the ecosystem. And also the implication of nanotechnology is nanotech will lead the rapid improvements in quantum computing and artificial intelligence. So now to the human health in the field of medicine. There are quite a few technological development that promises enhanced diagnostic possibilities, new ways to monitor patients, new ways to treat disease like cancer to reduce side effects. To give a few example, nanoparticles can be used as a carriers for targeted drug delivery. Their ability to penetrate certain protective membranes in the body, such as blood-brain barrier that can be beneficial from many drugs.
The impact of nanotechnology on human health and environment are by detecting pollutants by specific sensors. We can help to protect the sustainability of human health and also the environment that would be discussed later on after this. Thus, nanotechnologies provide us with a new approach to cut down the waste production. Thank you.
Good day everyone, my name is Genevieve Elisa Y. Mendoza from BPED 4B. So this is the continuation of our report of implications of nanotechnology on human health and the environment. So let's move on to the environment. Nanomaterials can be used to assist with cleaning the environment and even provide efficient energy solutions, such as nanomaterials-based solar cells. However, there are both positive and negative impact on the environment due to the nanotechnology. So let's move on to the positive impact. With the help of nanotechnology, water quality can be improved. Some of the nanomaterials can be used to remediation of the water. Another new technology is known as nanofiltration, which can be used in the water treatment in homes, office, and industries. With the help of nanotechnology, toxic gases with the air can be cleaned. Nanotechnology provides a solution to clean the contaminated water and prevent the new pollution. So we have the negative impact. Nanomaterials can also have a negative impact. Currently, there is very little information describing the relative environmental risks of the manufactured nanomaterials. Only a few studies have been conducted with the aim of discovering the direct and indirect exposure to nanomaterials, and there are no clear guidelines to quantify the effects. Again, we are the Group 3. Thank you for listening.